Assalamu alaikum. This is Riaz Patwari, BSc in Software Engineering. My ID number is 2930. So here I made a software for the apart from the pre-expansion process of AES. Then where I made the includes studio.h and also include the studio string.h and also include AES.h. And here I define the number of column comparing the state in AES. This is the constant in AES value of 4a value 4, and where I define also that the number of 32 bits the words in a key and key length in a bytes, and also the number of rounds in AES cipher. And for this reason, I use the reduce the code size considerably with the Kale ARM compiler, and also this link for the more important. And then I use this one and the private. I took the private variable to state the array holding the intermediate the result during decryption. And then the type depth unit 8 the state of 4. I took the array element, and then the array the stored the round keys. And then here the key input to the AES program, and then the initial vector used to only for the CBC mode. And then I stop this one using the end if, and then the lookup table at the marked constant to the can be held the read only store, read only storage instead of RAM, and also the below the can be configured dynamically for ROM or for RAM. And here I took the S box for completing this AES process. And here is the whole process of the AS box and also S box here, and another S box is here. For this one, I used to take the private function here to get this number this to return the S box and also return the R box. And this function produce the round keys. These round keys are used in the each round to decrypt the states. That's why I use this one. And also I use this the temper used for the column and order operation. The first row round key is the key itself, and where I see the for I use the for loop to calculate this one the round key and also the key. And then all other round key are found from the previous round keys. That's why I use this again the nested loop here, the for loop again and also the for loop. And then I use the condition, if else condition, where this function that rotates the 4 bytes in a row word to the left once. And this is the becomes this from this one it becomes this one, and it will the function root word. That's why I use this one. And also for then the sub word function is a function that takes the 4 bytes input word. That's why I use the again this function. And also I use the else if in this function we use the calculate again. And then this function adds the round key to state. The round key is added to the state in the XOR function. That's why I use this the static void add round key method, and where this the parameter is the unit 8 round. And then I calculate it again using this for loop. Here is a nested for loop. The subbyte function substitution the value in this and state matrix with the values in the S box. Using this S box, I calculate once again using the nested loop. And then this shift rows, the function shift rows is the state in the left, and each row is shifted with the different offset. The offset equal row number dot. So the first row is not shifted. That's why I use this again this function, the shifted rows method, to complete this side and this row after the one column to left. And then this area is I completed the rotate second row to column to the left. And then we use the third column and left. By this way it completed the shift rows area. And then I took the for this mix column, I use the another method which is the mix column method, where it will calculate the mix method from the multiply. The multiply is used to multiply with the shift rows. And then I found this one, and I will multiply again to complete this mix column. The static void in this inverse mix column to avoid this one. And here is I took the integer I and also the for use again the for loop to multiply this one, the mix column, and the sub byte function the substitute the values in this state matrix with values in h box. I took again the h box to the inverse substitute by to the decryption, and then I again I again multiplied the everything using this one and inverse shift rows again. And then the cipher takes the main function that encrypt to the plain text. That's why use the again the static void cipher void, and where the round equals 0, add the first round to the key state before the starting the rounds, and add round key I there will be the nr round and also nr minus one round. That's I use this the for here is the use the for loop the sub byte and shift byte mix column and add round key round. Heard the I took the parameter as a round in this method. The left round is given below. The mix column function is not here in the last round. Sub byte shift rows add round kernel. And then the static void inverse zipper, once again the unit b round equals 0, add the first round key to the before starting the round. That's why I use this one. I took this function for this function, there will be an around, and use the again the for loop to show the inverse shift rows, inverse sub byte row, add round key and else mix column. And also this one to by this way the static void block copy where this the output I equal to input e. If they define the ECB the void attribute block copy and this one, and by this way I have done this area for the decryption, and I complete the skip the key expansion of is the key first 0, and then the unit B, the XOR with IB input and input the state in the ciphertext or the Kalyan. If the remind the code copy, block copy is the schematic, the void AES 128 bits, the CBS decrypt buffer, and then it will skip the expansion in the first as a 0. And if IB is the first as a 0, we contains the encrypt without the reasserting in the inverse. That's why you use the again the for loop to complete the block copy state, the inverse sweeper and input the Killian and output once again it will take the one increasing by this way the block copy input the memset the stick in the zipper text. And this is the whole process of this AES process to complete this the zipper text and also the encryption. And so now if I want to run this code, and I will see that there is a problem in this the 195 number line this problem, but unfortunately I could not find this problem. That's why I could not run this code. So thank you, sir.